Do you really know what happens to the salmon you are about to prepare? We trust in the quality and cleanliness of U.S. salmon. But are there any hidden corners being kept secret behind the doors of those giant processing plants? Let's explore these secrets together, and perhaps you will be quite surprised about the true journey of this familiar dish. Before exploring the processing procedures, let's first define what clean means when talking about food, especially salmon. Is it just a matter of not having disease-causing bacteria? Or does it also include the origin, farming methods, and processing procedures? Our perception of clean can vary, and this will be the very foundation upon which we will evaluate whether U.S. salmon truly meets those standards. What criteria do you think a clean salmon needs to meet? Many salmon farms in the U.S. are adopting recirculating aquaculture systems (RAS). This is an advanced model that helps control water quality, limit environmental pollution, and optimize production. However, this system still has lesser-known disadvantages. One of them is the stress experienced by the fish. Salmon are migratory by nature, accustomed to strong currents, so when raised in closed tanks, they easily become stressed, affecting their growth rate and meat quality. Besides that, being confined in closed tanks also significantly increases the risk of disease spread among the fish. To control the situation, the use of antibiotics and various chemicals during farming is unavoidable, and this is a factor that consumers have the right to question regarding potential drug residues that may remain in the final product. Speaking of meat quality, there's an interesting fact that few people notice. The characteristic pink-orange color of wild salmon is completely natural, coming from their diet, which includes krill and small shrimp rich in astaxanthin, a natural pigment. In contrast, farmed salmon in farms often do not have access to this nutrient source. To ensure an appealing color for farmed salmon fillets, farms often have to add synthetic astaxanthin to their feed. Although it has a similar structure to the natural substance, artificial astaxanthin is usually produced from sources such as petrochemicals or even genetically modified microorganisms. Another difference between wild and farmed salmon lies in the omega-3 content. Wild salmon have a natural and diverse diet, which helps them accumulate higher levels of omega-3. Meanwhile, farmed salmon are often fed industrial feed such as fish meal, fish oil, and processed foods, which can lead to lower omega-3 content in their meat compared to wild salmon. And would you believe that in the U.S., some companies have successfully developed genetically modified GMO salmon with the aim of faster growth and reduced production costs? Thanks to the insertion of a growth hormone gene from another fish species, GMO salmon can grow twice as fast as normal salmon. Despite being approved by the FDA, many experts and consumers still have concerns about the long-term safety of this type of genetically modified salmon for human health. In addition, if these GMO salmon escape into the natural environment, they could have unpredictable impacts on wild salmon populations and local ecosystems. What a surprising story about the salmon farming industry. But does the journey of these fish end there? As soon as they arrive at the plant, the salmon will undergo an initial quality check, where their freshness, size, and any signs of damage are assessed. After that, they will be taken to the processing area, where they are rinsed with water. Do you wonder where this water comes from and what the treatment process is to ensure hygiene? Typically, processing plants use treated tap water, and they may have additional on-site filtration and disinfection systems to ensure the highest hygiene standards are met. Are there specific criteria for discarding fish that don't meet the requirements at this stage? Absolutely. The criteria may include the temperature of the fish upon arrival, their external appearance, ensuring they are not bruised and the skin is intact. The smell, it should be fresh, not fishy, or have an odor of decay or ammonia. And sometimes even rapid microbiological tests are conducted. Next, the salmon will undergo the main processing, which includes removing the scales, gutting and eviscerating, and removing the head, if necessary. This step is often carried out using both modern machinery and the skill of the workers. After that, the fish will be transferred to the filleting department. Can you imagine the sharp blades that separate the salmon fillets from the bones? Nowadays, there are also automated systems that can perform this task with speed and high precision. But the supervision of workers is still needed to ensure no meat is wasted. For example, there is a manual filleting method that helps keep the meat looking better, while the mechanical filleting method is faster for large production volumes. The skill of the person filleting or the accuracy of the machinery can both affect the amount of meat left on the bones. To ensure hygiene and prevent cross-contamination, the equipment and work areas are cleaned and disinfected regularly. The workers involved in these steps must strictly adhere to personal hygiene rules, including wearing gloves, aprons, and hairnets, as well as washing their hands frequently. A crucial step to ensure consumer safety is the inspection for parasites. Do you know how this process is carried out? Typically, the salmon fillets are passed over a light table, candling. The strong light helps experts detect any parasites that may be present in the meat. What happens to the fillets that are found to contain parasites? These fillets are usually discarded or treated using special procedures, such as freezing at extremely low temperatures for a specific period to kill the parasites. Are there any regulations regarding the number of parasites allowed in a batch of salmon? Yes, regulatory bodies like the FDA have regulations on the permissible levels of parasites in fish products to ensure consumer safety. After filleting and parasite inspection, the salmon may undergo various other processing steps depending on the final product. For example, the fish can be cut into smaller portions, and the skin or pin bones can be removed. Have you ever wondered about the effective methods for removing pin bones while maintaining the aesthetic appeal of the fish fillet? There are many methods, including using specialized tweezers to pull out each small bone, or using automated machinery that can remove the bones. In addition, some products may be treated with antimicrobial solutions or preservatives to extend their shelf life. What antimicrobial solutions are commonly used, and are they safe for human health? Some commonly used antimicrobial solutions include peracetic acid or chlorine dioxide at very low concentrations. They are considered safe when used according to regulations and are usually rinsed off afterward. The use of preservatives in salmon must comply with FDA regulations. Only approved substances and permitted amounts are allowed. Once the processing is complete, the salmon will be carefully packaged. Have you noticed the different types of salmon packaging on the market? Some are vacuum sealed, while others are placed in plastic trays and wrapped in film. Why is there this difference? Vacuum sealing helps remove air, prevent oxidation, and extend shelf life. Other types of packaging may be used for different purposes, such as displaying the product. Which type of packaging helps preserve salmon best? Vacuum sealing is generally considered one of the best methods for preserving the freshness of salmon. In addition, product labeling is very important. Typically, labels need to provide information such as the product name, origin, e.g. farmed Atlantic salmon, weight, name and address of the manufacturer or distributor, list of ingredients, nutritional information, and safe handling instructions. To ensure the salmon remains fresh and safe during transportation and storage, proper freezing and storage are crucial. Processing plants often use rapid freezing methods, such as blast freezing, to minimize the formation of large ice crystals, which helps preserve the structure and flavor of the fish. Do you know how the freezing speed affects the quality of salmon? The faster the freezing, the smaller the ice crystals that form, which helps minimize cell damage and preserve the texture of the fish meat better. The ideal storage temperature for frozen salmon to prevent the growth of bacteria is -18 degrees Celsius or 0 degrees Fahrenheit or lower. Salmon processing plants in the U.S. operate under strict procedures, but there are still lesser-known issues. The quality of water used during processing is an important factor, and plants often use treated tap water or other water sources that are regularly quality checked. However, there are still concerns about the risk of contamination. Food processing plants, including those for salmon, must comply with strict hygiene regulations. However, have you ever wondered, with the large quantities of fish being processed continuously, whether maintaining a completely sterile environment is truly easy? There have been reports of bacteria such as Listeria or Salmonella being found in some seafood processing plants. The causes could stem from inadequate cleaning of equipment or insufficient waste management procedures. What do you think about this? Are there certain standards that are being overlooked during mass production? In addition, some pre-processed salmon products may contain preservatives, such as sodium benzoate or phosphates, to extend their shelf life, which can affect their nutritional quality. Although their use is permitted in certain amounts, does the use of chemicals affect the quality and safety of the product in the long run? Or are there other preservatives added to extend the freshness of salmon after processing? We need to question the transparency of the use of these substances. Some salmon processing plants in the U.S. employ immigrant labor at low wages and under harsh working conditions. High production pressure can lead to errors in the processing and quality control procedures. High-grade salmon is usually processed carefully, but lower-grade products may not be as strictly controlled, potentially posing a risk of contamination. We've already learned about the candling process, but did you know that not all parasites are visible to the naked eye? Some parasites are very small and can only be detected under a microscope. So, is the current inspection process truly effective in completely eliminating this risk? If consumers don't cook salmon thoroughly, what health risks could arise? Although there are procedures in place, the speed of the production line and worker fatigue can also affect the thoroughness of the inspection process. The FDA regularly conducts scheduled and unannounced inspections of food processing plants. However, with the large number of plants, comprehensive control remains a challenge. Sometimes violations are only discovered when incidents occur. So, after everything we've explored, is U.S. salmon truly as clean as we often think? The answer is likely much more complex. Although there are efforts and regulations to ensure food safety, the hidden corners in the processing still need to be recognized by consumers. U.S. salmon, despite being strictly controlled, still has many hidden aspects from the farming process to processing. Consumers need to be more vigilant when choosing products, prioritizing wild-caught salmon or those from certified sustainable farms. Hopefully, this video has provided you with valuable information and helped you gain a deeper understanding of the salmon processing industry in the U.S. Do you have any thoughts or experiences you'd like to share? Please leave a comment below. Thank you for watching, and don't forget to like and subscribe to the channel so you don't miss our next interesting exploration videos. Goodbye and see you next time.